classroom or in working with some of his students. He's got a herd of PhD students that are about to graduate. And so it would be very good to, get them jobs in South Africa. We'd love to keep them in the country. Our students are now, there is a bit of a crisis in geophysics. As most of you know, WITS is the only geophysics program in Southern Africa. There's been a number of programs closed in Australia, and our students are being recruited. I just lost one of my MSc students. I say lost, I mean, she's going to part-time, to a company in Dubai. So the Middle East and the oil companies are starting to notice us and start to recruit. So it is important to develop more student support in geophysics. So I'm going to talk about our physical property efforts in understanding the Bushveld Complex, and also some of the plans we have for the ICDP Bushveld borehole. Freddie has already spoken a little bit about that, and Bob Trumbull also, and I'm going to continue with some of that and talk about some of our geophysics that we'll be doing. I just had to put this slide in. It shows Carol and I looking at a computer and our geological colleague in the background. And I wanted to mention a few things that I'm not, unfortunately, going to be able to talk about too much. Is there's one of the conversations I had yesterday, so I just stuck this in, was, we have a lot of core, but we didn't do downhole geophysics, and it takes too long to do the physical properties on the core. Well, the Australians have developed a core system that you just shove it through, and you can get susceptibility and density from that. I think also the operating system at the ICDP also has one of these systems. And the big problem with it is bringing the cesium source in for the density measurements. But you can basically do the same measurements that you do downhole on the core. And that would be very useful in many cases. And unfortunately, we don't have that in South Africa. But, and I'm not sure how many countries actually have that and use it, but it's worth bringing that technology up to the front. One of the big other issues I had conversations with about last night was how often do I sample? That's a big conversation. I think that should be a separate talk some other time, but it really is important that we learn to sample our data correctly for what we're trying to do. A lot of people are undersampling and aliasing their data and then saying geophysics doesn't work. And I wanted to point out a colleague, Glenn Naila, who's actually doing a lot of work in machine learning and working with a lot of these data. So just to refresh our memory about where our favorite borehole is, well, my favorite borehole, BV1, it's the Bellevue core, and it's up in the northern lobe, and here's where it's placed in the local geology. And I want to point out the moored copy borehole over here. And why I say it's my favorite borehole, I spent a year of weekends there with Lou collecting susceptibility and density data. So we already had something like quite a bit of the data was already in books, and we transcribed the rest of it, or we collected the rest of it, and Lou transcribed all 100,000 measurements from these handwritten notes into a database. So this is the kind of work he likes to do. Some people like this kind of work, so that's great. But we would sit there and collect susceptibility data. So that was 900 meters of core. Here's the other 2,000 meters of core. So we collected 109,000 susceptibility measurements and 2,200 density measurements, all by hand. So it can be done. And what we got, Bob went through this already. I just want to point out some of the data. This is just to refresh your memory about what the key looks like and where and Moose, I'm just going to say the upper zone for me starts where I can see magnetite because I see it in the susceptibilities. And then the densities over here, where we see these very interesting upward grading density trends. And we compiled a lot of the data by lithology, trying to get mean measurements for different lithological units, trying to see where there were some unusual things going on, and getting an average value for the Bushveld to use in our geophysical modeling. When I first started this project, there was like 15 density measurements on the Bushveld actually published. So we have added a tremendous amount of data to that. And it's very important that these data become publicly available. Yes, the densities do vary throughout the Bushveld, but we don't really have enough data to say how they vary and where they're going and what trends there are. We need access to those data. Okay, so my office is down the hall from Gordon Cooper, so naturally I applied wavelet analysis to what I was working on, and we come out with kind of an average cycle of about 100 to, between 75 to 125 meters for each one of these layers throughout the upper zone and the main zone. It looks like about the same thickness. And we've interpreted these as magma influxes, thickness of magma influx. So this is our amalgamated sills, if you will. And why there's no chill margins, I'll leave that for the geologist to decide on. This is what the physical property data shows us. This is a little bit of an innovative diagram. Each one of these horizontal lines, think of it as a histogram of the data. So we call this a windowed histogram image, which is just showing us how the statistics change throughout the borehole. And one observation that I've made, that I've argued with my colleagues on, Ben will probably disagree with me, but at the bottom of each one of these little units, well, nearly at the bottom of each one of them, there seems to be a granite layer. Now, is this thin granite? It comes in much later. Is it tracing out a weak zone? Is it intruding along that? That's something I'd like to look at further for sure. So the downward infiltration model for these upward trending density units, which Bob actually showed earlier also, we see they're over and over in the lower part of this Bellevue core. Sorry. And the model that was published by Ben Hayes and all of our group was that there was downward infiltration of dense overlying magma. Whether or not this would erase any kind of boundary, I don't know. So let's look now at the moored copy, which is continuing on the stratigraphy down below that. And we see in moored copy, sorry, have I done? Oh, no, I went too far. That's not moored copy. Sorry. I guess moored copy got left off of here. I will deal with that later. Sorry about that. Let me move on to my student, Obone Sepato, who did a whole project on boreholes and borehole data from Anglo-American, and this is an example. It's a little hard to see over here, but this is one of the it's the SO borehole just below or near Stale Drift, and unfortunately he's plotted them on their side, so we can't quite see them very well. And he was very afraid of criticizing our work on the Bellevue, so you can see he only put in the upward trending density lines, even though it's very clear that we have several cases where the density actually has has higher densities at the bottom of the trend. So here we have kind of a sawtooth trend as opposed to just upward trending. And I don't know if each, the whole thing is a unit or they're separate units, and some are bringing down dense material and other ones have dense material coming in on top, but he's got a number of boreholes in that area that show the same pattern. So it's quite interesting to see the difference. And then this is, sorry about that, we'll get to this in a moment, but this is the CH7 borehole, which is near our Bellevue, near the core we're going to be drilling. Now, one of the things we can do is talk about quality control. It's really essential to look at your data and have quality control on it. Now, I really like this kind of diagram. This is the Bellevue data. It's just density versus susceptibility colored by lithology. And you can see immediately, you know, this has been mislabeled as a northosite. It's clearly some kind of magnetite or magnetic gabbro. And these are probably not anorthosites either because they have a density of 3.4. That's, you know, beyond ridiculous. So it gives us a very quick way of checking that our data makes sense. And it also gives us a very quick way of looking for data quality issues. Now, I'm still baffled about what's going on here. I don't want to say which exact borehole this is, but this is published in Obone's thesis, which you can download from the internet. WITS has a very nice system where you can download all the MSc and PhD thesis. It's called Wired Space WITS, and you just download things. And we can see here this kind of really regular spacing. Was a decimal place left off the data, or was the instrument not recording the full range of its capabilities? And you can see here where the densities at certain points are locking into lower quality measurements, whereas in between they are, you know, getting the full range of measurements. So there's definitely some things going on. And this kind of a, you know, density versus susceptibility diagram really shows these quality issues up very well. Okay, so the next one I'm going to look at is our location of our new borehole, the Bushveld drilling project, ICDP project. And I want to point out this line number 4 is a seismic line that was collected by the government as part of the National Geophysics Program back in the late 80s. So in the late 80s, the South African government collected a whole bunch of seismic data, and these are available at the Council for Geoscience. And this is the geological map of that area. This is the R37, which I'm sure many of you have driven along. I will give you some more context here. This is Marula Mine outline here. This is our proposed borehole location. And we see that we've got a very nice seismic line just about 4 kilometers away, which gives us some confidence of where we're drilling. We've got a borehole almost directly on that seismic line, borehole 8172. And my MSc student was just snaffled by this Dubai company. Her project is actually putting all these geophysical data together and characterizing the area. So we've got the 4 boreholes from Impala, and this is where the CH7 borehole is located. Our proposed borehole is here. Unfortunately, we don't have access to the material from the other boreholes. And I put this up because I love working diagrams. This is a lot of discussion and agony trying to figure out from the map what's upper zone, what's lower zone, sitting with geologists, trying to sit it out on what the seismic data looks like. These are beautiful seismic data, and they haven't even been processed. They've been interpreted once by the USGS, and I think Fiona Sargent looked at it, and that's about it. So it really hasn't been looked at in great detail. This is obviously the Transvaal dipping here. And if we zoom in on the upper part, and I apologize, I forgot the marginal zone, which should be right in here, we see very, very clearly, and we can correlate it with this borehole. We see the Merensky Reef and then the UG2. The Merensky Reef actually shows on outcrop on the geology map, so we know where it is on the geology. And if we drop that right down, it intersects with this reflector. We know the Merensky reflector is much lower amplitude than the UG2 reflectors, and so we see this beautiful reflector. This is now the edge of the Transvaal, and that's this giant reflector coming up here. And the basal ultramafic sequence we get a beautiful reflector in that because we've got this huge zone of olivine here coming through. So that gives us a tremendous contrast between the more plagioclase rich rock above it and this olivine rich rock below it. So that's going to be a very exciting reflector to work with, and we'll see that in the data. So if we look at the susceptibility data, we see where the olivine has altered. That's why we're getting all these magnetites. But interestingly, this thick zone shows very little alteration. So there's little magnetite. I do want to point out there's this so-called dolerite intrusion, but we didn't see that on the seismic line. So they've gone through a 150-meter dolerite intrusion, and we don't see it on our seismic line 4 kilometers away. If something's 150 meters thick, we expect it to be quite extensive. So I would expect to see it on the seismic. We actually think it is the edge of a magnetic dike, because if we look at where the magnetic dikes are, this is high-res aeromag here coming through. Here's CH1, CH6, CH7, where we have our data. And if you just extend that dike a little bit further, you see that it actually intersects it. And you can see from the dikes, they're actually quite wobbly. So please use your aeromag data. And we were very glad to see that most of Marula is actually quite free of these dikes and silts. So we are hoping, well, we've got the aeromag. This is helicopter flown at 35-meter flight height, so it's quite low data. And what are our plans for ICDP? Well, Musa is very keen to run the DAS, the distributed acoustic sensing, fiber optic cable down the borehole. This will be a first to take it down such a deep borehole. And it measures strain, not velocity or acceleration. We are developing a physical property lab at WITS. These are some old equipment, but you start with what you have. We've got susceptibility, we've got density. We're looking at how porous our rocks are and what procedures are best to use. One of the things we have noticed on some of the mines is that some procedures are allowing rocks to get wet before they're weighed in air. So if you're spraying your rocks to look at them, as geologists seem to do, please get an oven and dry your rocks out before you weigh them in air. It makes a huge difference to the densities you'll get, even on non-porous rocks. We've got seismic velocities that we measure on the actual core itself. So these are, we've got a number of publications out about this. And really interesting how the velocities don't change that much in the Bushveld compared to, say, an oil and gas industry. And it's the densities that are giving us our reflectors. We're looking at a magnetic reversal innovation. That's kind of my baby. And I'm not going to go through that, just to say that we've developed a way of looking at the declination as a way of tracking magnetic reversals. And this is my last slide. It's some work by Bill Morris on one of our boreholes, where he's just taken the 3-component magnetometer data from the optical televiewer, which most of the time companies don't even request. It's in there, request it, because that can help us define where we have magnetic reversals. And we had a question earlier about the squid magnetometers. Well, the squid magnetometer is sensitive enough to see these magnetic reversals in the aeromag data. So if we can really get these ideas of where these magnetic reversals are in something that's very quiet, like the main zone, we can start to look for some of these features of where these magnetic reversals might be mapped out. So I'll leave it there with some scenes from our Bushveld drill site and looking at the National Core Repository of South Africa. If you haven't seen it, please have a look. I had to go visit my favorite core again. And we have archived ZF007. And we're looking forward to lots of physical property projects and please collect your physical property data. Speak to us if you want information, and we'd love to help you. Thank you. I hope I didn't.
One quick question.
Yeah, I did cut into your lunchtime. I apologize.
Questions?
Oh, okay.
Thank you very much.
Join us. There we go.